So actually base is linear independent and linear dependent. Linear combination பத்தி பார்த்துட்டு and then move for the inner product space. So இங்கே பார்த்தீங்கன்னா first of all linear combination means V be the vector space over F. If v1 v2 vn belongs to V, then any element of the form, that is v1 alpha 1 v1 plus alpha 2 v2 plus and so on alpha n vn, each alpha e belongs to the field F, is called the linear combination over F of எதனுடைய linear combination v1 v2 vn உடைய linear combination. So that means alpha e come from the field F. Only finite many vectors can be combined at once. So the zero vector is always a linear combination. Zero vector is always the linear combination. So and another very important definition, linear span. So that means linear span means S is non-empty subset. S is any non-empty subset of a vector space V. The L of S, then L of S, the linear span of S, L of S is the set of all linear combinations. Linear span of S means the set of all linear combination of the finite set of elements of S. Finite set of elements of S. The collection of all linear combination of the finite set of elements of the S is called the linear span of S. Linear span of S. The linear span of S into the surface of V. Linear span of S into the surface of V. So easily we can verify that suppose if you take the any two element V, W in L of S now. So there exists a finite subset, that is S1, S2, Sn is the subset of S, T1, T2, Tm is the subset of S. These are finite subset. There exists the scalars lambda 1, lambda 2, lambda n, mu1, mu2, mu_m. So we can write V and W in the linear combination of that finite set because of V and W or linear span of S என்றதுனால linear span of S ல இருக்கிற element என்றதுனால we can write the linear combination of so V, W ன்றது L of S ல நாம எடுத்தாலே S ல இருக்கிற finite set கூட ஓகே S ல இருக்கிற finite set கூட linear combination என்னால எழுத முடியும்னு அர்த்தம். அதான் V and W ன்றது. So நாம prove பண்ண வேண்டியது that is the alpha V plus beta W எங்க இருக்கணும், that is belongs to L of S ல இருக்கணும். இருந்ததுன்னா that is called the surface. L of S is a surface. So alpha into V, beta into W போட்டேன்னா alpha உள்ள மல்டி பண்ணா alpha V1, alpha n and lambda n. Okay, but that is what about the alpha and beta na, that is the field element. What about the lambda 1, lambda 2, mu1, mu2, mu_m under the field element? So alpha lambda 1, alpha lambda n into S1 and beta mu1 into T1, beta mu_m Tm under the is always belongs to L of S because of that is the linear span of S, because of the elements S1, S2, Sn, T1, T2, Tm is all of them finite set, that finite subset of S. Finite subset of S. So the linear combination is always belongs to L of S. So alpha V plus beta W belongs to L of S. Therefore L of S is a subspace of V. It's a very important one. And these are some properties. So some properties, suppose ST ன்றது subset of V இருந்ததுன்னா then S is a subset of T and S and T are subset of V. if S is the subset of T இருந்தனா that is implies L of S is subset of L of T. அதே மாதிரி L of S union T equal to L of S plus L of T. L of S equal to L of S. These are very simple proof. Proof தெரிஞ்சுக்கிறது ரொம்ப நல்லது for ஞாபகம் வச்சுக்கிறதுக்கு ரொம்ப ஹெல்ப்ஃபுல்லாக இருக்கும். So then S is the subset of T, that means then any linear combination of the elements of S is also linear combination of the elements of T. The same way, these are a very simple idea. Leave it. And another very important topic, that are finite dimensional. So the vector space V is said to be finite dimensional over F. Finite dimensional over F if there is a finite subset in V such that V equal to L of S. V equal to L of S. That is called the finite dimensional. That is very important concept, very important definition. The finite dimensional means the vector space V is said to be finite dimensional அப்படி நாம சொல்லணும் over the any field F. If there is a finite subset S in V, V க்கு ஒரு finite subset exist ஆகணும், அதனுடைய linear span is equivalent to V இருக்கணும். அதனுடைய linear span of the finite subset of the V is equivalent to V இருந்ததுன்னா the V is called the finite dimensional over the any field F. Okay, for example பார்த்தீங்கன்னா F power n is a finite dimensional over F. F power n என்றது finite dimensional over F. S consists of n vectors. S consists of n vectors, that is E1, E2, En, and then any vector A1, A2, An belongs to Fn can be written as A1, E1, A2, E2, that is any element. ஏதோ ஒரு element Fnல இருக்கிறது, that is linear combination of these two, that is A1, E1, A2, E2, An, En. E1ன்றது இது. அப்படின்னா A1 மல்டி பண்ணிங்கன்னா A1 0 0 0ன்னு வரும். இது பார்த்தீங்கன்னா A2 மல்டி பண்ணிங்கன்னா 0 A2 0 0ன்னு வரும். இது ரெண்டுத்தையும் ஆட் பண்ணிங்கன்னா ஃபஸ்ட்டு ரெண்டு பொசிஷன் A1 A2 வரும். இதே மாதிரி n டைம் ஆட் பண்ணும்போது we get it this one. So any element, any vector F over n can be written as like that. That is from the what is the conclusion? எல்லா எலமெண்ட்டையும் என்னால் இது மாதிரி எழுத முடியும் அப்படின்னா the V equal to L of S எழுதலாம். V equal to L of S. That is a very important idea, very important one, the finite dimensional definition. And another very important linear independent. Another important linear independence, V is a vector space. V is a vector space, V1, V2, Vn belongs to V. We say that they are linearly dependent over the any field F. V is a vector space, vector V1, V2, Vn belongs to V. We say that linearly dependent over F, that vector. That means if there exists an element that's in the field F, that is alpha lambda 1 lambda 2 lambda n, alpha 1 alpha 2 alpha n, not all of them 0, எல்லாமே 0 கிடையாது, something non-zero இருக்கலாம். But the linear combination of the scalar and the vector should be equal to 0. எல்லா ஸ்கேலாரும் 0 கிடையாது, but the linear combination equal to 0 na, then the corresponding vector are said to be linearly dependent. எதெல்லாம் linearly dependent இல்லையோ that is called the linearly independent. That means இன்னொரு observationல என்ன சொல்லலாம்னா that is all of them should be equal to 0. The linear combination equal to 0 na, all scalars should be equal to 0 இருந்தா lambda 1 lambda 2 lambda n equal to 0 இருந்தா then that is called, the corresponding vector is called the linearly independent அப்படின்னு சொல்லலாம். linearly independent சொல்லலாம். இது ஒரு முக்கியமான கான்செப்ட். ஓகே, முக்கியமான கான்செப்ட். தட் இஸ் so if a vector are linearly independent, then none of them can be zero vector. So vector வந்து linearly independent, none of them can be zero vector. அதாவது that means v1 v2 vn இதுவே zero vector இருக்கணும். Suppose if v1 equal to 0, then 1 into v1, 0 into v2 and so on equal to 0, so with not all coefficients 0. So the single non-zero vector is always linearly independent. Single non-zero vector is always linearly independent. Linear dependence is related to the field F. Okay, these are very important observation. And F power 3, the vectors on the 3 vector எடுத்திருக்காங்க. 1 0 0 0 1 0 0 0. This is a very base vector that is our linearly independent. These are also linearly dependent. So that is 2 into something plus 1 into something, that is minus 1 into something. This is equal to 0. Not all 0 into 1 minus 1. So that is called that linearly dependent. Okay. So the dependence on the field. So consider the complex number C as a vector space over R, over the field R. The vector 1 into 1 and 1 comma I are linearly independent. That means A into 1, B into I equal to 0 na, with A comma B belongs to R, then A and B should be equal to 0. Then only it is possible. So therefore 1 comma I are linearly independent. So but 1 comma I linearly dependent over C, over the complex number. So that means I into 1 plus minus 1 into I, so equal to 0 with the coefficients I comma minus 1 belongs to C, not both equal to 0. ரெண்டுமே வந்து 0 கிடையாது. So therefore this is called the linearly dependent. So the same problem 1 comma I is linearly independent over the R, but over the C, over the field C, these are linearly dependent. That is the very important one. Okay. And another very important idea, L of S is the smallest surface containing S. L of S is the smallest surface containing S. S is linearly independent and L of S equal to V. Then S is called the basis for V. S is called the basis for V. And the dimension of V will be defined as the size of the largest linearly independent set. Largest linearly independent set is called the dimension of V. And if V1, V2, Vn is belongs to V or linearly independent, then every element in the linear span as a unique representation in the form of like that. The very earlier I பார்த்தது. So that is there some set of vectors is a linearly independent na. Every element in the linear span, that is means every element in the linear span has a unique representation in the form of lambda 1 v1 plus minus 1 lambda n v1. That is the linear combination of that vector with the lambda I belongs to F. So we can unique என்றதனால that is ரெண்டு எடுத்துட்டு that is unique அப்படின்றத ப்ரூவ் பண்ணலாம். linear independentன்றதனால coefficient 0வா இருக்கும். And if v1 v2 vn are in V, then either they are linearly independent or some vk is a linear combination of the preceding ones. இதுவும் ரொம்ப important concept. ஒன்று அது linearly independent இருக்கணும், இல்லை some element preceding this. That is v1 v2 vn as a linearly independent, that is either there are linearly dependent and there exists something linear combination, not all 0. So k with the largest integers, that is alpha k, is not equal to 0, then all I greater than k alpha I equal to 0. So therefore alpha 1 alpha 2 alpha k vk equal to 0. So then vk we can express in terms of alpha k inverse into something, alpha k inverse into something எடுத்துலாம். That is minus alpha 1 minus alpha k minus 1 எடுத்துட்டு alpha k inverse into இதெல்லாம் வந்து belongs to So vk is the linear combination of its preceding ones. அதுக்கு முன்னாடி இருக்கிறதுல linear combination எடுத்துக்கலாம். It's a very simple proof. And so v1 v2 vn in v have w is a linear span, and if v1 v2 vk are linearly independent, then we can find the subset v1 of v1 v2 vn of the form like this: v1 v2 vk va1 var consisting of the linearly independent elements whose linear span is also w. அதனுடைய linear span is also w. And another one, V is a finite dimensional vector space. That is a very important idea. V is a finite dimensional vector space. Then it contains a finite set v1 v2 vn of linearly independent elements. Okay, then it contains a finite set v1 v2 vn of linearly independent elements. அதனுடைய linear span is v. Linear span is equivalent to v ன்னு அர்த்தம். ஓகே, இதுதான் நம்ம L of s equal to v ன்னு சொன்னோம். And so that is the example. So v equal to r cube, and we have the v1 v2 v3 and v4. So with w is the linear span of the vectors v1 v2 v3 v4, so then that is equal to r cube. So we know that v1 v2 are linearly independent, so that is v3 equal to v1 plus v2, that is dependent in preceding. So v4 is independent of v1 v2, so the final base is v1 v2 v4. So that is and another very important idea, basis. A subset S of a vector space V is called the basis of V if S consists of the linearly independent elements. S consists of the linearly independent elements, and that is any finite number of elements in S is linearly independent. Any finite number of elements in S is linearly independent. That is, S consists of the linearly independent elements. Okay. So and V equal to L of S, the linear combination of S. So linear span of S, V equal to L of S. S spans V ன்னு அர்த்தம். So இந்த ரெண்டு கண்டிஷன் சாட்டிஸ்ஃபை பண்ணுச்சுன்னா, that is the subset S of a vector space V is called the basis of V. ஒன்று வந்து S is linearly independent elements இருக்கணும், இன்னொன்று L of S equal to V இருக்கணும். Okay. And every vector in V can be written as unique linear combination of the basis element. And basis is a maximal linearly independent set. Basis is a minimal spanning set. These are very important. For example, basis of R2, standard basis of R2, இதெல்லாம் நமக்கு பேசிக்காக தெரிஞ்சிருக்கும். That is called the 1 0 and 0 1. அதே மாதிரி basis, standard basis of R3 1 0 0 0 1 0 0 0 1, and basis of space 2 by 2 matrix. So basis of for the space 2 by 2 matrices 1 0 0 0 1 0 and 0 0 1 0 and 0 0 0 1. This is form a basis of for the vector space 2 by 2 matrix with real entries, and the basis for the space of the polynomial of degree less than or equal to 2, that is a set 1x x square, that is a forms a basis for P2 of R equal to, that is the space of polynomial of degree less than or equal to 2, 1x x square form a basis. This is a form a basis for P2 of R. That means polynomial of degree less than or equal to 2 the coefficients is the real number. The polynomial coefficient is the real number. That is the notation. That means a0 a1x plus a2x square, ai belongs to R. So 1x x square is the formula basis. CSIR NET la romba helpful ah irukum. And basis for R power n. This is already R2, R power 3 பார்த்தோம், the same idea. Okay, and basis for the space of continuous function. So continuous function உடைய basis பார்த்தீங்கன்னா the set of 1 sin x and cos x. 1 sin x cos x form a basis for the surface C of 0, 2 pi spanned by 1 sin x cos x. This is the basis for the surface of the C of 0, 2 pi. That means what is the idea? That is a continuous function on the interval 0, 2 pi that is spanned by something. And V is the finite dimensional vector space. V is the finite dimensional vector space, and V1, V2, Vm span V. Then the sum subset V1, V2, Vm forms a basis of V. So that is connection with the finite dimensional space and the basis. V into the finite dimensional vector space. Okay, and u1, u2, vm into the span V, that is a linear span of this one equal to V. Then u1, u2, um into the form a basis of V. u1, u2, um into the form a basis of V. That is a very important one. And basis size, this is also very important one. And v1, v2, vn into the basis of V over the field, any field f. w1, w2, wm என்றது are linearly independent over f. இது பேசிஸாக இருந்தால் இதுதான் பெருசாக இருக்கணும், அப்போ தான் m less than or equal to n. அதுதான் முன்னாடியே பார்த்தோம், இந்த ப்ராப்பர்ட்டியே பார்த்தோம். The basis means that is the greatest, இதுதான் largest linearly independent செட்னா இருக்கும். அப்படின்னா இன்னொரு linearly independent செட் நான் எடுக்கிறேன்னா that is should be less than or equal to and the basis nuடைய number of element க்கு less than or equal to தான் இருக்கும். So the base is the largest independent set. Base is the largest independent set. And another very important idea, dimension. So V is a finite dimensional over F, finite dimensional over F. That is then any two bases of V. Any two bases of V have the same number of elements. So that is also very important one. So V1, V2, Vn, W1, W2 two bases na edukrana. This is a basis W1, W2 linearly independent na edutha munnadi result apply panna m less than or equal to n. Suppose either basis na eduthittu innona linearly independent edutha m less than, that is n less than or equal to m nu vandurom. Renduthi combine panningina m equal to n nu vandurom. Appadina enna kedachirchi, that is the two bases have the same number of elements nu vanduchu. Na distinct number of elements na edutha. And another very important one, f power n is isomorphic to f power m. f power n isomorphic to f power m na m n equal to m nu irukum. Okay, but that is also very very important one. So இது மாதிரி சிம்பிளாக தான் கேட்பாங்க, டிஆர்பி பொறுத்த மட்டும் ரொம்ப காம்ப்ளிகேட்டடாக கேட்க மாட்டாங்க. f power n basis consisting of n vector e1, e2, en, and similarly f power m as a basis with m vector. Okay, similarly f power m as a basis with m vectors. Okay, so then an isomorphism between the vector space maps the basis to basis. That means preserves the linear independence and spanning. That means if f power n is isomorphic to f power m na, that is the rendu bases same or same number of elements. Rendu bases irukuna the same number of elements irukunu. That is n equal to m. Converse pattern n equal to m nu edutha, that is obviously coordinate based identification gives then isomorphism. That f power n is isomorphic to f power m. Another idea, V is the finite dimensional over f. V is isomorphic to f power n for a unique integer n. N is the number of elements in any basis of V. N is the number of elements in any basis of V over F. Okay, V is a finite dimensional. V is isomorphic to F power n. That is a very important one. For a unique integer n. For a unique integer n. In fact, n is the number of elements in any basis of V over F. That means n is the number of elements in any basis of V over F. And integer n, that is in the corollary, is called the dimension of V over F. So that is denoted as dimension of V over F, that is dimension of V when the field is clear. That is the dimension of V is n, that is the V is isomorphic to F over n, or the basis contains the n elements. The basis contains the n elements, then dimension of V is equal to n. So any two finite dimensional vector spaces over F of the same dimension are isomorphic. Is the munadi isomorphic F over n, F over m isomorphic. So then m equal to n. That is the finite dimensional space of vector space over F of the same dimension, ஒரே dimension இருந்ததுனா they are should be isomorphic. So V is a finite dimensional over F, and U1, U2, Um belongs to V, or linearly independent, then can find the vectors from um plus 1, um plus 2 and so on, um plus r in V. Then this is linearly independent. V into the finite dimension over F. So we can extend the vectors from um plus 1 to um plus r in V such that the collection u1, u2, um plus 1, um plus r is a basis of V. Is a basis of V. Okay. Remember, this is the extension property. Any linearly independent set can be extended to a basis. And a dimension of r power n equal to n, dimension of r power n over the field R equal to n, dimension of C power n over C is equal to n, but dimension of C over the field R equal to 2. The basis memorize பண்ணலாம் 1, I is the basis. 1, I is the basis. This is a very important one. The space of the polynomial of degree less than or equal to 1 as a dimension n plus 1 over the any field. நாம் ஏற்கனவே பார்த்தோம் dimension less than or equal to polynomial degree less than or equal to 2 to 1x square less than or equal to 2 க்கு 3 வருது. So less than or equal to n க்கு n plus 1 as a dimension n plus 1 over any field. The basis into the set of all coordinate axis for the space. Dimension of the number of independent direction in the space. The isomorphs into the two space are the same. The same are the structure. They have the same number of independent directions. Structure wise same are that is called the isomorphism. And V is a finite dimensional and W is the subspace of V. Then W is finite dimensional. V is finite dimensional, W is finite dimensional. Dimension of W less than or equal to dimension of V. So dimension of V by W is always equal to dimension of V minus dimension of W. So இது எல்லாமே ரொம்ப முக்கியம். Okay. Particularly and the last one, third one is very important. And dimension formula for the sum of the subspaces. This is also very important. If A and B are finite dimensional subspace over the vector space, vector space V, then A plus B அதனுடைய sum பார்த்தீங்கன்னா is a finite dimensional. அதோட dimension பார்த்தீங்கன்னா dimension of a plus b equal to dimension of a, dimension of b minus dimension of a intersection b, dimension of a intersection b. So when you define the linear transmission T from a cross b to a plus b, that is T of a comma b equal to a plus b. So that is clearly linearly surjective, that is and the kernel T we can define like that. That is a comma minus a is the kernel T, the collection of a comma minus a. Pi is defined from the a intersection b to kernel T, pi of x equal to x comma minus x. So this is an isomorphism. So the linearity, that means pi of alpha x plus beta y, that is a homomorphism, and injectivity 1 to 1 and surjectivity on 2. So the dimension of kernel T is equal to dimension of a intersection b. Therefore, when you apply the rank nullity theorem, that is dimension of a cross b equal to dimension of kernel T plus dimension of imaginary of T. That means dimension of a cross b equal to dimension of a plus dimension of b, dimension of kernel T equal to a intersection b. So dimension of imaginary of T equal to a plus b. So from this, dimension of a plus dimension of b equal to dimension of a intersection b, dimension of a plus b. So it is a very important formula. Okay. The rank nullity theorem is a little bit தெரிஞ்சுக்கணும். And this is the already discussed idea. Using the quotient space we can prove this one. And in R cube, W is a plane, and V by W is a line, that is a one-dimensional space, and indeed the 3 minus 2 equal to 1. So for two planes in R power 3, if they intersect in a line, that is dimension of A, dimension of B equal to 2, and dimension of A intersection B equal to 1, dimension of A plus B equal to 2 plus 2 minus 1, that is equal to 3. If they are parallel, if they intersect in a line, that is the dimension of A plus B. So that is if they are parallel, then dimension of A, dimension of B, dimension of A intersection B equal to 0. If they are parallel, then dimension of A plus B equal to 4. So but this is impossible in R power 3. The formula correctly tells us that the parallel planes, the same space must intersect. Okay, the same space வந்து intersect பண்ணிக்கும் அப்படினா. And b equal to r power 4, that is let a equal to x comma y comma z comma w. What are the condition? That is x plus y equal to 0 or z equal to 0. X, y, z, w, the collection is x equal to 0, y plus z equal to 0. So what is the dimension of A means? So that is equal to 2. That means the basis is 1 minus 1 0 0 0. Okay, that is the add பண்ணீங்கன்னா 0 வரும். And the collection of elements x plus y equal to 0 or z equal to 0, z equal to 0 here. So these two form a basis for this one. And the dimension of b is also equal to 2, so 0 1 minus 1, that is y plus z equal to 0 and x equal to 0. So these are form a basis. எல்லாமே 0 வர்க்காது. So dimension of b equal to 2. So a intersection b ரெண்டுத்தினுடைய intersection பார்த்தீங்கன்னா, so that is 0 0 w, w belongs to r. So dimension of a intersection b equal to 1, and dimension of a plus b equal to, by the formula, that is equal to 3. Dimension of a plus b equal to 3. This is a very important example. And the dimension of a and b are subfaces of b, with the dimension of a plus dimension of b greater than dimension of b, and then a intersection b is not equal to not only 0. A intersection b is not only 0. So then this is a very simple idea, that is a dimension of, this is the formula, this is less than or equal to dimension of b. So dimension of a plus dimension of b minus dimension of a intersection b less than or equal to dimension of b. But given that this is dimension of a plus dimension of b greater than dimension of b, whatever the dimension of a intersection b should be greater than 0. This is should be greater than 0, a intersection b should be not only the I0 elements. the mari f is the field of real numbers, then 1 1 0 0 0 1 minus 1 0 and 0 0 3 in n power 4 is linearly independent over f. So what condition on the characteristic of f would make the three vectors in the result A linearly dependent? What condition on the characteristic of f? So first of all, linearly independent proof panna, that is alpha into something, beta into something, gamma into something equal to 0 0. I will try to find out the alpha, beta, gamma value that should be equal to 0. அது எல்லாமே ஜீரோவாக இருந்ததுன்னா linearly independent. இங்கே பார்த்தீங்கன்னா that is alpha, so that is the linear combination, that is alpha plus beta. இங்கே alpha மீதி எல்லாம் ஜீரோ ரெண்டுமே. இங்கே ஆல்ஃபா வரும்பொழுது this is alpha, இங்கே பீட்டா, இங்கே ஜீரோ, ஆல்ஃபா ப்ளஸ் பீட்டா. அண்ட் இங்கே பார்த்தீங்கன்னா இங்கே ஜீரோ, இங்கே -1 அப்படின்னா மைனஸ் பீட்டா வரும். ஸோ மைனஸ் பீட்டா. அண்ட் லாஸ்ட் ஒன் பார்த்தீங்கன்னா இங்கே ஜீரோ, இங்கேயும் ஜீரோ, இங்கே மட்டும் 3 காமா. ஸோ ஈக்குவல் டு 0 0னா ஃபஸ்ட் ஒன் ஈக்குவல் பண்ணிங்கன்னா ரெண்டு வெக்டார் ஈக்குவல் டு 0னா ஃபஸ்ட் ஒன் ஆல்ஃபா ஈக்குவல் டு 0ன்னு வந்துடும். கடைசி ஒன் காமா ஈக்குவல் டு 0ன்னு வந்துடும். ஆல்ஃபா ஈக்குவல் டு 0 அண்ட் இங்கே பீட்டா ஈக்குவல் டு 0ன்னு வந்துடும். ஸோ எல்லாமே ஜீரோ ஆகிடுச்சு. ஆல்ஃபா பீட்டா காமா ஈக்குவல் டு 0. ஸோ எல்லா வெக்டாரும் எல்லா ஸ்கேலாரும் ஜீரோனா தட்ஸ் மீன்ஸ் ஸோ த வெக்டார்ஸ் ஆர் லீனியர்லி இண்டிபெண்ட் ஓவர் ஆர்னு அர்த்தம். ஸோ த வெக்டார்ஸ் பிகம் த லீனியர்லி டிபெண்ட் if there exists a scalar alpha beta gamma belongs to f not all 0 such that alpha beta is something equal to 0. So from the system we get something, the first three equation alpha beta equal to 0. The only possibility of the non-trivial solution is if 3 gamma equal to 0 as non-zero solution. So that means if 3 equal to 0 in f, then gamma should be not equal to 0. இது எப்போ நடக்கும் அப்படின்னு பார்த்தீங்கன்னா the characteristic of f divides 3. Characteristic of f divides 3. So that means characteristic of f equal to 3 na 3 equal to 3 in f, 3 equal to 0 in f. Then we can take gamma equal to 1. That means non-trivial linear combination equal to 0. So the characteristic of f equal to 3 இருந்ததுன்னா அவங்க அதை தான் கேட்குறாங்க. characteristic of f என்ன இருந்ததுன்னா that's linearly dependent ஆகணும். Suppose characteristic of f is not equal to 3 and 3 is not equal to 0 in f, so should be gamma equal to 0, that is linearly independent. So the vectors are linearly dependent இருக்கணும்னா that is if and only if characteristic of f equal to 3 characteristic of f equal to 3 இருந்ததுன்னா that is called the linearly dependent. Okay, it's also very important. So V has a basis of n element, V has a basis of n element. So then V is isomorphic to f power n. That is V is isomorphic to f power n. n elements இருந்ததுன்னா ஆல்ரெடி நம்ம வெரி ஏர்லியராக நம்ம இதுதான் பார்த்தோம்னு நினைக்கிறேன். So that is another result பார்த்தீங்கன்னா T is an isomorphism of V onto W. T is isomorphism V onto W. Then T maps the basis of V to basis of W. Okay, T is an isomorphism of V onto W. அப்படின்னா basis of V onto basis of W. T maps. Okay, this is also very important. And V is a finite dimensional and T is an isomorphism of V onto V. Then T must map V onto V. Must map V onto V. And this is V is a finite dimensional and T is a homomorphism, and T is a homomorphism of V onto V. then T must be 1 to 1 and so on isomorphism. Finite dimensional irundhuduna T is a homomorphism from V on to V irundhuduna V is finite dimensional irundhu, then T must be 1 to 1. T must be 1 to 1 so that this is an isomorphism. Okay, this is also very important. இது கேட்பாங்க 1 to 1 அந்த ஆப்ஷன் கொடுத்துட்டு finite dimensional homomorphism இருந்தால் V on to V, then the V T must be 1 to 1. That is a very simple proof in the linear algebra, not a difficult one. And V is a dimension, V is of dimension n, V is of dimension n, that is any set of n linearly independent vectors in V form a basis of V, form a basis of V. The case of V is dimension n, and in finite dimensions, surjective implies the injectivity for a linear map. This is a consequence of the diagonality theorem, that is special nature of the finite dimensional spaces. In n dimensional space, any maximal linearly independent set that is with n element must be basis. And V is a finite dimensional and W is a subspace of V, and dimension of V equal to dimension of W, then V equal to W, then V equal to W. So V is a finite dimensional, T is a homomorphism of V onto itself, V to V, which is not onto, only into. முன்னாடி onto varna T is 1 to 1 பார்த்தோம். This is only into, not onto. Then there is a some non-zero vector in V, then Vt equal to 0, then Vt equal to 0. And F be the field, let f of x be the polynomial. F be a field, let f of x be the polynomial in x over f. Then f of x is not a finite dimensional over f. F enter the field, f of x enter the polynomials in x over f. So f of x is not a binary dimensional over f, because I suppose contradiction f of x is a finite dimensional over f now. What is the meaning? That's with the basis p1 of x, p2 of x, pm of x basis, that is capital N equal to maximum of degree of pi of x. Capital N enter the numerator. So capital N enter the maximum of degree of pi of x. Then any linear combination that is ai pi of x, that is I is varies from 1 to m as a degree at most n, அதிகபட்சம் என்ன இருக்கும் n தான் இருக்கும். அப்படின்னா x power n plus 1 belongs to f of x cannot be expressed as such a linear combination. So this is a contradiction to the contradiction. So therefore f of x is a infinite dimensional, not a finite dimensional, that is the infinite dimensional. So therefore this is a contradiction to our assumption, that is not a finite dimension. This is Vn is defined as the collection of the polynomial degree of p of x less than n. Define the transformation t of alpha naught alpha 1. எப்படி டிஃபைன் பண்ணியிருக்காங்க, that is t of alpha naught alpha 1 x and so on alpha n minus 1 x power n minus 1. So alpha naught plus alpha 1 x plus 1, alpha 2 x plus 1 whole square plus and so on alpha n minus 1 x plus 1 whole power n minus 1. Then that transformation t is an isomorphism of Vn onto itself. And W is defined the collection of the polynomial of n minus the degree polynomial, and the sum of the coefficient equal to 0, sum of the coefficient equal to 0, Then W is a subspace of Vn. That is also very important. In the case of the collection of polynomial, the sum of the coefficient equal to 0 is the subspace of the Vn, the collection of polynomials, and also basis of W over F. What is the basis of W over F? So இங்கே P of X என்றது that is the n minus of the degree polynomial collection. நான் Wல ரெண்டு எலமெண்ட் நான் எடுக்கிறேன்னா that is n minus of the degree polynomial நான் எடுக்கணும். இந்த கோஎஃபிஷியன்ட் வந்து இங்கே ஆல்ஃபா இ, இங்கே கோஎஃபிஷியன்ட் வந்து பீட்டா இன்னு எடுத்துக்க. தட்ஸ் ஆல் ஐடியா. Wல இருக்குனாவே இந்த சம் ஆஃப் த கோஎஃபிஷியன்ட் ஈக்குவல் டு 0, சம்மேஷன் ஆல்ஃபா இ சம்மேஷன் பீட்டா ஈக்குவல் டு 0. A, B belongs to F. ஸோ நான் வந்து லீனியர் காம்பினேஷன் கண்டுபிடிக்க போகிறேன். ஸோ APX plus BQX. So when you apply that formula, summation A alpha I plus B beta I into x power I ன்னு எடுக்கலாம். So this is equal to, and summation I equal to 0 to n minus 1 A alpha I plus B beta I ரெண்டு பார்ட்டாக ஸ்ப்ளிட் பண்ணி எழுதலாம். ஈச் அண்ட் எவ்ரி ஒன் எனக்கு ஜீரோன்னு தெரியும், அதனால் டோட்டலாக ஜீரோ ஆகிடுது. அப்படின்னா திஸ் இஸ் இந்த கண்டிஷன் சாட்டிஸ்ஃபை ஆகுது இந்த பாலினாமியலுக்கு. இது சாட்டிஸ்ஃபை ஆகிறதுனால திஸ் இஸ் அ சர்ஃபேஸ். W is a surface. So basis of W over F. What is the basis of W over F? So what are the conditions? Sum of the coefficient equal to 0. Sum of the coefficient equal to 0 na இதில் இருக்கிற ஆல்ஃபா n மைனஸ் ஒன்னுன்றதை அதனுடைய முன்னாடி இருக்கிற ஸ்கேலாருடைய லீனியர் காம்பினேஷனாக என்னால் எழுத முடியுதுன்னு அர்த்தம். ஸோ பாலினாமியல் W have the form summation I equal to 0 to n minus 2 alpha x power I minus summation I equal to 0 to n minus 2 alpha I into x power n minus 1 equal to என்ன பண்ணலாம், that is the alpha I காமனாக வெளியே எடுத்துட்டோம், x power I minus x power n minus 1. So this is the x power I minus x power n minus 1, I equal to 0, 1, 2 and so on n minus 2 spans W ன்னு அர்த்தம். And also this is the linearly independent, and also this is the linearly independent and the so hence this is the form a basis, this is the form a basis. So then dimension of W equal to the degree is n minus 1, dimension of W equal to n minus 1. Okay, and V1 V2 Vn be a basis of V, W1 W2 Wn be any n elements in V. This is the basis of V, this is the n elements in V, be any n elements in V, and define the transmission T on V by T of lambda 1 V1 plus lambda 2 V2 lambda n Vn equal to lambda 1 W1 lambda 2 W2 lambda n Wn. Then T is the homomorphism of V into itself, V into itself. That is on the linear combination வந்து prove பண்ணணும். That is the homomorphism. Is it a isomorphism? That is bijective prove பண்ணணும். இங்கே V ன்றது finite dimensional. This is equivalent to T being the injective, that means kernel T equal to 0. இது ரொம்ப முக்கியமான ரிசல்ட், நேற்றே பார்த்துக்கணும்னு நினைக்கிறேன். kernel T should be equal to only the identity element, that is 0. So that so T is an isomorphism. T is an isomorphism, and T is an isomorphism, that is must be linearly independent. So T is isomorphism if only if the W1 W2 Wn is the basis of from a basis of, and the homomorphism of V onto V into itself when V is a finite dimensional. That is from the previous problem, we can by choosing the appropriate element W1 W2 Wn, okay, can be choose the element W1 W2 Wn is a basis. That is W1 V1 V2 Vn basis of V, and the same problem Wi into alpha I1, that is linear combination of the V1 V2 Vn. Wi, each Wi is a linear combination of V1 V2 Vn. Then n square elements alpha ij belongs to F determine the homomorphism of T. And another very important problem, mostly you here the example, that is the dimension of V equal to n, then dimension of homomorphism of V comma V, that is n square, that is n into n, n square, like that. Okay, it's a very simple proof. So V is a finite dimensional and W is a subspace. V is a finite dimensional and W is a subspace of V. Then there is a subspace W1 of V, that is V is the direct product of W and W1. W under the subspace, and there is another subspace W1 of V. In the case of V is finite dimensional, we can express the V equal to the direct product of W and W1. It's also very V is a vector space, then its dual space, is called homomorphism of V comma F, homomorphism of V comma F. V is a vector space, other dual space is a homomorphism of V comma F, and F is the field, So homomorphism of V comma W is a vector space over F. Under the operation, how to define the T1 plus T2 of V equal to T1 of V plus T2 of V, alpha T of V equal to alpha into T of V. So this is the one of the important lemma. And if V and W are of dimension m and n, then the homomorphism of V comma W unit dimension m. இதுவும் கேட்டிருக்காங்க நிறைய அப்படி very earliest stageல நிறைய தடவை கேட்டிருப்பாங்க. And dimension of V equal to m, and dimension of homomorphism V comma V equal to m square, dimension of V equal to m, and homomorphism of dimension of homomorphism V comma F equal to m. This is a very important one. The distinguish between the homomorphism of V comma V is m square in the case of dimension of V equal to m, but the homomorphism dimension of homomorphism V comma F is m da, not m square, that is over the field F, that is equal to m da. And V is a finite dimensional and non-zero vector V belongs to V, then there is an element F belongs to V star such that F of V equal to 0, F of V equal to 0. And when V is a finite dimensional, then the natural map some omega from V to V double star is an isomorphism of V onto V double star. And V is a vector space, then its dual space is already part of homomorphism V comma F. The V star means homomorphism V comma F. Then W is a subspace of V, then annihilator of W is defined as the collection of the elements from the homomorphism of V comma F such that what is the condition of F of W, F of omega equal to 0 for every omega belongs to W, that is W belongs to W. And homomorphism W V comma W is a vector space over F, then the operation already defined. And V and W are the dimension m and n respectively over the field F, and dimension of homomorphism V comma W is of dimension m n. Already பார்த்ததுதான், இதுவும் already discuss பண்ணதுதான், இப்போ repeat ஆயிருக்கு. And V is of finite dimensional and W is a subspace. W is a subspace of V, then W star is isomorphic to V star divided by A of W. A of W is the annihilator. That means A of W, F of the collection of F, F of W should be equal to 0. W is the element of W. So that is V star by A of W. A of W is the annihilator. And dimension of A of W is equal to dimension of V minus dimension of W. This is very important. Okay, W is a subspace, V is a finite dimensional on the W star is isomorphic to V star divided by A of W with the condition dimension of A of W equal to, that is dimension of V minus dimension of W. அதே மாதிரி annihilator of w equal to w. So the system of homogeneous linear operations like this alpha ij belongs to f is of rank r, then there are the n minus r linearly independent solution for this system. So this is the n dimensional, that is the n equation, that is m equation, n variable, that is the rank is r, rank is of rank r means that is there are the n minus r linearly independent solution, n minus r linearly independent solution இருக்கு அப்படின்னு அர்த்தம். நீங்கள் 12th ஸ்டாண்டர்டில் கொஞ்சம் எடுத்து பார்த்தீங்கன்னாவே யூ கேன் அண்டர்ஸ்டூட் some homogeneous equation க்கு the rank means what is the rank? Rank is அதோட dimension, that means independent variable வந்து n இருந்ததுன்னா n minus the rank of r, rank m minus rank is the number of linearly independent solution for that homogeneous system of equation. And n greater than m, that is the number of unknown exceeds the number of unknown exceeds number of equations. There is a solution x1 x2 xn where not all of are 0, not all of 0, எல்லாமே 0 இருக்கும், some non 0 இருக்கலாம். That is also very important. Okay, so and to prove that a of w, that is the annihilator of w, is the surface of V. That is already we know the definition of annihilator of w. We can easily prove there is the surface using the linear combination concept. The linear combination is belongs to a w means that is the surface. It's a very simple proof. And another one for the S is a subset of B, and A of S is defined as the collection of the V star element, and f of S equal to 0 for every element S belongs to S. Then A of S equal to A of L of S. L of S is the linear span of S. That is also very important. So A of S is the subset of A of L of S. A of L of S is subset of A of S. So from this A of S equal to L of S. அதே மாதிரி U1 is the subset of U2 or subset of V, then A of U2 is the subset of A of U1. And S comma T is belongs to homomorphism V comma W. So two linear transmission homomorphism from V to W. VIS equal to VIT for every element Vi of the basis of V, then S equal to T, then S equal to T. With homomorphism V comma W is a vector space over F. So from that details, that is we can prove easily this is a property of all properties are satisfied. So this is a vector space, and psi denote the mapping used that is V into V cap. This is the complete, that is psi is a vector space homomorphism from V into V cap. It will be easy enough to leave it. And V is a finite dimensional. V is a finite dimensional, and V1 is not equal to V2 or in V. Then there is an F belongs to V cap. So how to express such that f of V1 is not equal to f of V2. So ஒரு finite dimensional vector space க்கு ரெண்டு different distinct element exist ஆச்சுன்னா அதனுடைய corresponding image is not equal. Okay, but the reason f belongs to V cap. அதே மாதிரி W1 W2ன்றது subspace of V na the which is a finite dimensional describe A of annihilator of W1 plus W2 in terms of W1 A of W1 and A of W2. So நமக்கு A of W na என்ன definition தெரியும், that is annihilator definition. So here we can easily prove that is A of W1 here W1 in terms of W1 plus W2 here W1 intersection here W2. So that is how to prove this something. F belongs to A of W1 plus W2, that means F of W equal to 0, W is belongs to W1 plus W2, that is the idea இல்லையா. So the annihilator definition is A of W1 plus W2 means this is the F of W equal to 0, W belongs to W1 plus W2. So since W1 is the subset of the something and W2 is also subset, so for each W1 belongs to W1, W2 belongs to W2, F of W1 equal to 0, F is belongs to something, so F is belongs to A W1 intersection W2. So from this A W1 plus W2 is the subset of the something. The same way this is a subset of this one proof பண்ணலாம். So from this both are equal now. Okay. அதே மாதிரி dimension finite dimensional and W1 W2 are subspace of V. A of W1 intersection W2 intersection in terms of A W1 and W2, that is also equal. That is the same proof. And so F is the field of real numbers, then A of W A of W is spanned by 1 2 3 and 0 4 minus 1 and W is spanned by something where W equal to இதுவாக இருந்ததுன்னா A of W என்னன்னு கேட்குறாங்க. A of W நம்ம கண்டுபிடிக்கணும். W is spanned by something. So W equal to span of 1 2 3 and 0 4 minus 1. So the linear function F belongs to R cube can be represented F of x y z equal to ax plus by plus cz for some abc belongs to R. We know the definition of the A of W, that means F of W equal to 0. Now F of 1 2 3 equal to A plus 2b plus 3c equal to 0. F of 0 4 minus 1 4b minus c equal to 0. இது ரெண்டுத்தையும் சால்வ் பண்ணிங்கன்னா ஓகேவா, தென் c equal to 2b இங்கே சப்ஸ்டிட் பண்ணிங்கன்னா we get it something a plus 2b plus 3 into 4b a plus 14b equal to 0, so a equal to minus 14b. So the solution என்ன அப்படின்னு பார்த்தீங்கன்னா, so abcன்றத minus 14 to t14 எழுதலாம், that is t times something, t belongs to R. So A of W is the collection of R cube star F of x y z equal to t into minus 14x plus y plus 4z. Am I correct? This is a linear combination of the something. So A of W is a one dimensional with the basis functional F of x y z equal to something. Okay, this is a A of W. அதே மாதிரி W spans the three element na. What is the A of W? Once again F of x y z W ன்றது linear combination அப்படி எழுதலாம், define பண்ணுறோம், that is F of x y z W. And F of the something apply பண்ண c minus d, the 2a plus b plus c minus d இது apply பண்ணும் பொழுது under the basis under the some element spanned element from this c equal to d ன்னு வந்துரும். அதை எடுத்து சப்ஸ்டிட் பண்ணிங்கன்னா abcல உங்களுக்கு c equal to d and the something 2a plus b equal to 0, b equal to minus 2a. The second equation substitute பண்ணீங்கன்னா that is c equal to 0, d equal to 0 and b equal to minus 2a, so cd equal to 0. So that is t minus 2t, a equal to t னு வைக்கும்போது t minus 2t 0 0 னு வருது, இதான் abcd. So this is the solution. So t into 1 minus 2 னு எழுதலாம், that is x minus 2y, t into x minus 2y f of x comma y comma z w னுடைய collection, that is the A of W. This is also one dimensional with basis functional, the x minus 2y. So dimension of a of w equal to 1. So this gives that the linearly dependent 2 1 minus 1 equal to something linear combination நம்மளால எழுத முடியுதுன்னு அர்த்தம். So therefore the span has the dimension at most 2. So dimension of w equal to 2, therefore dimension of AW equal to 4 minus 3. I thought this is equivalent to 2. Something wrong. R power 4, maybe this is wrong one. This is 3 R power. So 3 minus 2 equal to 1. Okay. Dimension 4, R power 4. The basis depend money, that is what are the bases. Something wrong. Okay. And find the ranks of the following system of homogeneous linear equation over R. Then find all the solution. There is the system of equation. The system of equation, the augmented matrix, corresponding augmented matrix, and the coefficient matrix, right hand side இருக்கிறது எல்லாமே 0. So அதை simply பண்ணீங்கன்னா reduce பண்ணீங்கன்னா we get the element. So after elementary transformation apply பண்ண பிறகு உங்களுக்கு like this இது மாதிரி ஸ்ட்ரக்சர் கிடைக்கும். எவ்வளோ மேக்ஸிமம் இந்த ஃபஸ்ட்டு இது ரெண்டுத்தையும் 0 ஆக்கணும் அண்ட் தென் ட்ரை டு இதை 0 ஆக்க ட்ரை பண்ணணும். ஓகே, பாசிபிளி இதை 0 ஆக்க ட்ரை பண்ணலாம். இது மேலே இதை ரெடியூஸ் பண்ண முடியல. ஸோ த ரேங்க் இஸ் 3 இயர். தேர் ஆர் த 4 வேரியபிள்ஸ் இங்கே. ஸோ த சொல்யூஷன் ஸ்பேஸ் ஆஸ் டைமென்ஷன் 4 minus 3 equal to 1. 4 minus 3 equal to 1 சொல்யூஷன் ஸ்பேஸ்னுடைய இது. And this is the solution space, that is the dimension is 1 and artham, dimension is 1. And another system of equation 131, அதனுடைய elementary transformation இதை 0 ஆக்க ட்ரை பண்ணணும், that is R2 minus R1. and then இதை 0 ஆக்க ட்ரை பண்ணிங்கன்னா that is the rank is 2, number of non-zero rows, variable வந்து 3. The solution space பார்த்தீங்கன்னா 3 minus 2 equal to 1. Dimension வந்து 1. So we can express that solution space using the formula x2 equal to 0 and from this t into minus 1 0 1. இங்கே x2 equal to 0 and final and the transformation போட்டிங்கன்னா x1 equal to minus x3. So x3 equal to 1 t எடுத்துட்டிங்கன்னா x1 equal to minus t, so x2 0, x3 equal to t, that is the linear combination. So the system is like this. இது மாதிரி இருந்ததுன்னா அதனுடைய reduced form இது எல்லாத்தையும் 0 ஆக்கணும் first of all, and then try to இது ரெண்டுத்தையும் 0 ஆக்க ட்ரை பண்ணணும், and then இதை 0 ஆக்க ட்ரை பண்ணணும். ஸோ அந்த எலிமெண்டரி டிரான்ஸ்மிஷன் ஆப்ரேட் பண்ண பிறகு ரேங்க் இஸ் 2ன்னு வந்துடுது. இங்கே வேரியபிள் 5 அப்படின்னா சொல்யூஷன் ஸ்பேஸ்னுடைய டைமென்ஷன் பார்த்தீங்கன்னா 3. சொல்யூஷன் ஸ்பேஸ்னுடைய டைமென்ஷன் இஸ் 3. ஸோ therefore 2 equal to minus 2 into x3 plus something, s plus t equal to. So solution space is the basis minus 2 into x2, x3, x4, x5. So minus 2 into 1 1 1, that is the s equal to 1, t equal to 0, u equal to 0. So solution space இது மாதிரி எக்ஸ்பிரஸ் பண்ணலாம் dimension 3ன்றதுனால. and f and g are in v cap and such that f of v equal to 0, that is implies g of v equal to 0. Then g equal to lambda f, lambda is belongs to f, lambda is belongs to f. And the simultaneous equation கண்டிப்பா பாத்துங்க, that is the dimension என்னன்றது. The next topic is the inner product space. Okay, the basis இன்னைக்கு பார்த்ததுல basis, span, dimension and system of equation கொடுத்தா how to find out the solutions based on the dimension. Okay, basis என்ன இதெல்லாம் கொஞ்சம் பேசிக்காக பார்த்துக்குங்க. See you in the next class.